Hello, happy Saturday. It's Saturday where I am, but happy whatever day of the week it is wherever you are. I hope you're having a great day and are well. It's only dropped about 36 hours ago, this new feature in Claude Code called subagents. I'm really glad that they've called it subagents rather than agents, because there are constructs that you can use where you can take things a lot further than the capabilities that subagents have. And I think obviously Anthropic have the vision to understand that's kind of what users are going to do and what maybe they're going to do. So calling them subagents was a superb naming convention. So what Anthropic do really well is they really understand how to actually simplify the MVP features for a CLI that give you the capability then to orchestrate them in complex ways. So a great example of that is sort of the init and the Claude.md, which you can specify at a global level. You can init a Claude.md and Claude code will go away and look at all your code, and it will create basically an initial template of all the technologies and conventions that the particular project uses, and you can go away and then customize that. So things like coding conventions, styling, the technology conventions, which technologies to use, you can fully control without having to pollute the main context. So it's an uber powerful, uber simple sort of paradigm to allow you to basically create workflows style outcomes without them going away and spending months engineering that. People are doing things with workflows anyway. There are projects out there to do things with it, but actually, in many ways, having the simplicity of using the Claude MD is actually absolute genius in terms of being able to leverage it. So that's a superb feature. They've done a similar thing with subagents. Subagents essentially piggyback on the back of something that's been inside Claude Code probably from the year dot. I say year dot. Claude Code hasn't been around that long, but it allows you to parallelize sort of generative AI in terms of using the model to basically spin up to 10 tasks, which can be running consecutively. You can spin up more than 10 tasks, but they'll be queued. And then as task threads become available, it will then start doing whatever task is waiting in the queue to be done. So it allows you to run those in parallel. So there are a number of reasons why that's great. A, they have their own context. So you're not polluting your primary context, and they'll come out with the emission of whatever that particular task was that will come back into your context, because you need to know something about what happened. And also you can run them essentially much faster. So if you've got 3 things you want to do and they make sense for them to be running in parallel, it'll essentially run 3 times faster because they'll be running in parallel. So the downside to that is obviously you'll be using more tokens. So it's always a sort of balancing act between token usage and how fast you need something to be done. But essentially, sub agents piggyback right on the back of tasks. And essentially what they allow you to do, that you can create task-specific workflows that allow you to do common things that you want to do, fully define how these things work with their own context. So again, each one has its own context. So in terms of defining an agent, it's pretty simple, really. You give it descriptions, a high-level description of what the agent is. You then give it, which can be quite a complex, system prompts that what that particular sub-agent's remit is. And I'll show you some of those in a moment. You can then define which tooling to use, so you can completely focus it onto certain types of tooling, so that you go away and say, I only want you to use these toolings, so Claude doesn't get distracted and using toolings which maybe aren't relevant or you don't want it to use. And then you essentially define a prioritization, which is what it looks like inside the console. Once you've done that, that is then available essentially in a commands folder, which can either be at the global level in terms of your root.claude, your global Claude folder, or they can be an individual project. So you can ship these with the repo. So you can have repo-specific sub-agents that are specific to a particular repo, and they go with the repo, and as developers pull it, they pull down the common sort of sub-agents that are unique to that particular repository. So because of that, it's incredibly simple. You've got full customization of how you use these. You can have some that are globals and some that are sort of relevant to particular projects. So let's go away and fire up Claude, and then we'll have a little look at what we're talking about. So we're in Claude here, and then if we just go /agents is the new command. So it'll go away, and you can see what I've done here is I've gone away and I've created 4 agents. So I've created a code review specialist, which is generally just go away and review all the code, look for any potential issues that we might want to remediate. In all these 4 agents, actually, I've told it not to make functional changes in response to it, but to come out with plans that we go away and create subtasks to go away and tackle individual items rather than it keenly, which it will do, I'll try and go away and start doing them. So we don't want it to do that. So we've told it we want plans emitting from these. The second one is a feature enhancement advisor. I want to go away and look at the code and suggest features that we might not have even thought of yet, but looking at how the code works, what makes a sensible, really useful feature to a user that a user could use. And in UIs, it makes even more sense to be able to do that. We've got a web security auditor. So his primary task is to go away and look for security issues that are related to anything that's visible over the internet, because we might want to prioritize those, and a performance analyzer that's particularly focused on looking for issues that might cause over time performance issues. And this is a great example. You see this all the time with developers, where they're going away and they create this thing and they might be using link, for example. They might go away and they might have these repositories and they'll bang on includes, and suddenly this thing will become huge and it runs fine initially. But over time, as you get more data in the database, these things will suddenly become a problem. This is designed to go away and look at these things before we hit them at the time we've created it. So we don't suddenly do a release, excuse me. It worked on QA because QA has a very tiny data set. We get to production and suddenly everything slows down because we've got things in there which are non-performance. So it's particularly focused on looking for those performance issues ahead of time. So we've created these 4 agents. So when you create an agent, we've got an option to create an agent here. Essentially, all you do is you put in a high-level description, a sentence or two of what it does, and then you've got the option to either create it fully manually yourself, or Claude will go away and create a skeleton for you, which will basically, using that little synopsis of what you want to do, it'll create a fully featured skeleton that you can then go in and edit. And you can specify in there, as I've said, which tools to use and which colorization to use. We don't really need to create a new agent. It's as simple as it says on the tin. What you might want to do is, after you've created the agents, is customize them. So the thing here is, and what I'm going to cover here really is, you can also get performance improvements from Claude itself. So these particular 4 agents we've got here, we could run them in series, do the code review, do the feature enhancement, do the web security, do the performance analysis. But actually, because we're not making functional changes in response to it, we can actually run these in parallel. So that means we can potentially be finished 4 times as fast. Now, what happens is when you run up a task list, essentially, which these are based on tasks, it looks to me like Anthropic and Genius, they've already got a task feature. They simply piggyback this on top of tasks. So you'll be waiting for the longest running task to complete, but you won't be waiting for all 4 tasks to complete a series. Now, you can also specify run them in the series. So you've got full control over how these work. You can also specify in the high-level description a hint of when you might want these to fire off, in terms of do these after we've run the test, for example. Now, that to me initially seems a little bit hit and miss. So the best way of using them I found, and it's only been 36 hours, is to create a custom slash command. So you can create custom slash commands, which are basically simple prompts. And I've created a couple, one to run all 4 agents in parallel, one to run all 4 agents in series. So what do these agents look like? Sub-agents. I've got to stop calling them agents. There's a lot of interesting things we can do with what I call agents. And I think what's probably in Anthropic's head with agents, where we can do multiple things at the same time. So we can be working on multiple repos at the same time for different features. Now, we may want to do something in one repo first and another repo later, but we may want to be modifying a backend repo, for example. When we've made the changes for the backend, we might want to be modifying the front end. And then once we've done that, we might want to be firing up, and I showed you custom MCPs that can run APIs and exercise them as a user or a QA to actually kick the tires based on what it knows about how that API works. And we've done a couple of demonstrations now where we've done things where we've got it to understand how an API works just from figuring it out from the Swagger and iterating through it. And I've also shown you one where we've got it to create spec flow tests for an API, which was not well understood. And we got it to then, by creating the spec flow tests, it went away and understood really well how the API worked to produce a specification of how that very poorly understood API worked. It's a very simple API that we did for demonstration purposes, and we're actually going to run this on that API today for our demonstration. But it sort of allowed us to do these things that are really useful. So you can think of that then is not only can you use agents for modifying the back end, modifying the front end, running the back end, running the front end. So before Claude starts a task, and there are MCPs that allow you to do that. You can actually fire up the UI and go in there as a user. You can try out how it currently works. It can make suggestions about how to implement the feature. You can go away and implement the feature, and then it can go and run it afterwards and see whether the feature works. And, oh, actually, probably better if we did this. So there's a whole set of things that you can do with agents. And I've got some very interesting, very, very interesting things I'm doing with hooks. And we're doing multiple Claudes doing things at the same time that we'll cover at a later date, where you can do some very interesting workflows. And as you understand how to use this technology, I mean, there's so much flame about AI, right? Now, it depends on the tooling. How much time have you spent trying to use this tooling? I spent a couple of years, right? So I've built my own from scratch. I've used the best that's out there, and I've used all the tools. So I understand pretty well how to make generative AI work inside a tool set because I've studied it. But you've got to work at it in the right way to make it work. It's not just going to work out the box. You go in there and A, you're using a tooling which doesn't really work for you. You're not going to get good results. B, if you don't actually think how generative AI needs you to think, control context, control tasks, break things down into things which will fit into how the generative AI works, you're not going to get a very good outcome. And Anthropic completely understand this. It's not about mega context, 1 billion context, or 10 billion context. You don't really want to load all the code into context, and that's what Claude Code does really well. He uses sort of features, and we'll probably see it creeping away like a Trojan, trying to find things without having to load all the code into context. They completely understand that actually a relatively small context of 120K or whatever is really useful because it keeps you focused on what you're trying to do, keeps you focused on making the tooling do stuff well, and also keeps the generative AI focused on what it's doing. So it doesn't get distracted doing other things. And hallucination, I'm doing air quotes there, you can't see that because there's no camera. Hallucinations, I mean, people think these are just the generative AI has to make a decision about which token to get to next. And because of that, it's not really a hallucination. It's based on a process of iterating through a task, what makes most sense to do next. So it's not really hallucinating. It's based on everything it knows in the context, out of there, and all its knowledge, which is the best thing to do next. And the more stuff you've got in the context, the more chance you are you've got it deviating from what is probably obvious to you, but not necessarily obvious to the generative AI, because you may have given it a 1 or 2 sentence prompt, and then you think, oh, it's got to be a genius, it's got to figure it out. You've actually got to guide generative AI through that process. It won't be able to do it on its own. So what do these agents, sub-agents? Got to stop calling them agents. I've really got to stop calling them agents. Sub-agents, and I think they've deliberately called them sub-agents. I completely understand what Anthropic are doing with that terminology, because I can see where this goes next. So sub-agents. So we've got these 4 here. So basically you've got a name, you've got a high-level description, you've got colorization, so that you can see them in the console differently. It's quite useful when you're running them in parallel. And then you've got the full, essentially, prompt, which is the prompt for that agent. This agent then has its own context where this is injected to, and it does all its machinations in that context. And then all that comes out is the emission from the context. So you're not polluting your primary context. The other thing you can do, and I haven't really done it here, is you can specify which tools to use. And I've shown you a lot of custom MCPs now for calling APIs directly, interacting with proxy servers, interacting with databases, interacting with remote compute. I plan to do a lot of things, and I can already see I need to do a little bit more of human smarts to make it work. But what I can do is I can actually create sub-agents that leverage these toolings in a very easy to use fashion that I can go straight into a Claude Code solution. I can connect to a few things or get it. Basically, state management is key to how I can use these custom toolings. Because A, I want it to have the state when it loads, and B, I want it to have the state when it goes to a sub-agent. Because when it's firing up a sub-agent, I haven't fully explored this yet, but to me, it looks to me like if I was using tooling, it wouldn't have any context of things that I'd already done in terms of connecting to something, for example. So a state management MCP will allow me to work around that, and that's something I'm working on. Because I understand this technology well, I kind of already understood how they've done it, and I kind of already understand what I need to do to leverage it a little bit further for my particular use case, take this further, because we like doing things through Max here. Max is obviously quite Freudian in terms of Claude Code. If you know what Max is, you'll get the joke. But so essentially we've got one here. So we've got a code review specialist that's got a full remit of what its tenants are. It's got a web security auditor, and again, it's pretty much has a remit of what it needs to do. We can customize these over time, but you see there's common things in there. Wanting to look for XSS, CSRF, SQL injection, security misconfigurations. I mean, there's whole sets of agents that I could add on top of here. A great one is potentially a licensing agent. So you can see in the open source world, more and more open source is becoming less open source. So you've seen this with lots of projects like Automapper, Mass Transit, Fluent. A load of these have now sort of had the latest versions are now moving to a more closed license, and you've got the older version you can still use. But by default, if you pull down things from NuGet, you're going to get the latest version, and then you maybe use something which requires a license. So we could have a licensing audit which just goes away and check, are we infringing anybody's licenses? Do we really want the latest features of what they offer? Well, we need to pay them some money then because they're doing some work. So we need to pay them some money. So you can have other agents off the back of the fly, and you can create these quite quickly. So we've got one which is focused on performance. So a great example of why this would be useful. Say you're using Entity Framework and you're using Link. You see this all the time where developers create something on their local machine with probably a very tiny database, and they add and include and include and include and include for a thing on a repository method. And then over time, on their machine, it works fine. They go to QA, has a bigger data set, but probably still not massive. Probably a slightly more powerful instance, still seems fine. Get to production, she's probably got a BM-off instance, but even with a BM-off instance, with the masses of data that's in there, suddenly becomes unperformant. So you can use these agents to go away and look for these things before you have to find them by creating production database. I've even seen madness where people have, oh, we're going to take the production data and we're going to sanitize it and we're going to run everything against the production data. No, just go and look at the code and find it. And that's what generative AI can do for you. So we've got a tool which is specifically focused on that. We can optimize it over time. So, for example, I would probably customize this one to add more link-specific features that I want it to find, because I know what the common issues are that we have with that, because I've seen it time and time again. History repeats, and people have a short memory, and history repeats often if you don't sort of have a mechanism for catching it, because you have this thing, oh, I remembered this thing, and then I've gone away and done 20 things. You forgot that thing last month that went wrong. You've done these 20 other things. You get to the next month, oh, it's happened again. Call the police. Do you know what I mean? So you've got to be, sensible about how you go away and proactively look for these. Don't rely on finding them. And then we've got a feature enhancement one, which is focused on looking for features that may be something we might want to add in the future. And that makes probably even more sense on a UI, for example. So a feature enhancement advisor is great. Sub-agent is great because it can go away and we're doing it in the API. So add API features that might be useful. Add sorting, add a search capability. Those are the kind of things I'd expect this to find. As a UI agent, with some of the custom MCPs, what I intend to do is to get it to exercise the UI as a user, get it to then understand how it works, get it to then make suggestions about features that might make sense based on the remit of what it understands about the whole project. So these are 4 agents we've created for this demo. So we're in our little project that we've used before, our little API, and we're going to use the custom / command we've created. So we've got 2, and I call all my custom ones custom. The clue is in the name. So we've got 2, one to do the full analysis in parallel, one to do the full analysis in series. Sometimes it doesn't make sense to run things in parallel. If you want to run the tests and then modify the tests, and you have 2 sub-agents for that, then it doesn't make sense to modify the test before you run the tests, right? So you'd run those in series. For the kind of things we're doing with these, it makes perfect sense to run them in parallel. So we're getting 4 times the potential performance limited by the slowest running sub-agent to be able to do something faster in its own context. Obviously, chomping tokens in those contexts, but will come to an emission much faster than running them individually. So it just, again, leverages your performance for doing things with generative AI. And that's kind of, you need to understand how to make generative AI work. It's not, if you're going to lazily consume generative AI, you will be punished and your organization will be punished. You need to understand how it works. And the beauty of what Anthropic have done is just so simply executed that gives you a lot of options for constructing it in a way that works the way that you want it to work for your use case, because everyone's got an individual use case using different technologies. They've got different outcomes. They've got different things they're trying to do. So it makes sense to be able to optimize it. And that simplicity is the key to why Claude Code is so powerful. Oddly enough, I would much prefer to have the simplicity and full control of a CLI than to have a lot of obfuscated things being done for me by something that I can't control. So that's my preference. Whatever your preference is, that's fine. That's my preference. But then I spent a few years looking at how to leverage generative AI. So that's based on my own observations. You'll have your own observations over time. But what I have done is I've observed, and I've observed from the start, it's ain't going nowhere, this. And then very quickly, but what if I built this and I built this and I built this and I built this? And the models are getting better. Oh my goodness, I can compound these, I can orchestrate them, I can get this piggybacking of capabilities. I can have 5 features, and because I've got a tree of features, I've got 25 features now, because they can all run together to do a myriad of things I never thought possible. So that's how you need to think about leveraging generative AI. So what we're going to do, we're just going to run the parallel version of this. So what I'm going to do today, just to show you sub-agents. So we've got these, I've described what they are. So what you'll see is basically piggybacks on tasks. So you'll see 4, it's create a plan, so it'll create a to-do, and then what it'll do is it'll spin off these 4 sub-agents in parallel. And then what it'll do is, when they inject back from their context what they've done, it'll inject in the summary of what's happened to the primary context. So we're not polluting it with all the machinations of what it had to do to get the outcome. We're just getting the outcome, which is the most important thing. So we've now got 2 sub-agents running, code review, performance, we've got feature enhancement now running, we've got web security audits running. So they're all running in parallel. So we'll see those ticking along, and as they progress, you'll probably find some will finish before others, but eventually they'll all finish. And then what Claude will do is it has created itself a task at the end. It knows it's running tasks. It hasn't actually specified there that it's running tasks, but we've told it to run tasks. So it knows it needs to summarize the tasks, because we need something to join them all together. Otherwise, we're just going to end up with, sub-agent 1's finished, sub-agent 2's finished. What it's going to do is it's going to summarize the findings together. So we'll find out what it does when it gets to completion of what the expected outcomes are. So it's busy going away, and you can see it's going away, looking at files. We'll probably see a bit of grepping going on at some point, particularly probably with the web security auditor tool. I suspect that one might take the longest to run, and then we'll see what the outcome is when it's completed. So there are a lot of reasons why this is useful. So you can either have them at a global level, which is available to everything, but you can customize them. Particular projects may have particular sub-agents that only have relevance to those sub-agents. And then once you've got your own MCP tools, which may only have relevance to those projects, you can actually put those commands inside that project. They live with the repo. They go up with your push, your PR, and your merge, and developers get them as they pull them down. So that gives you the reusability of agents. Your global agents are reusable everywhere. Your project-specific agents are available to everyone. They have specialized expertise, so they're focused on one particular task, which is key to leveraging generative AI, is getting focused. Because you've got a limited context still. You've still got quite a reasonable context with Claude Code, but it's not crazily big. To me, that's a good thing, because it forces you to have focus, and it forces the AI to have focus. And again, you can give, you've got full control over access to tools. So there are 2 reasons you might want to do that. A, for controlling what the tooling is doing, and B, for sort of focusing the AI on what it's done. So 1 has already finished. The feature enhancement advisor has already finished. So again, this is firing away, and I've shown you my Hook demonstration. These are all firing away what's going on into basically a Hook database of all the actions that are carried out, so that you don't have the full visibility of what it's doing, because you're only seeing the current thing it's doing. But if you're worried about what it's done, if it's making a functional change, that's all in my Hook database, and I can go away and have individual AI agents. So I can have sub-agents which go away and summarize and look for things that I might not want it to have done as part of that after it's run, because it can go away and find them in the database. It's got database MCP tooling, so it allows it to talk to that database. It'll literally, as soon as it's connected to the database, it can use the database, because that particular tooling describes to the large language model the part of the code that's written, how the database is configured, how the schema works, so it can go away and do things without us having to craft prompts to be able to describe how the database works. So you can do a lot of powerful things with these. But again, the thing with tasks is they are less visible, so you need to bear that in mind. So you need strategies to think about how you deal with that, in terms of, you really want to be looking at anything that makes a functional outcome. You want to be looking at what it's done. So now we've got all 4 completed, and it's going away now. And what it'll be doing is summarizing the outcomes from all 4, and then we'll see what it comes up with. So it's now get to its final to do, which is basically summarize the findings. So very shortly, we'll see something appear, and then we can go away and have a look. And that's basically just gives you an overview of how sub-agents work. So hopefully that's given you enough to give you some ideas about how you could use sub-agents for yourself, and the potential powers of sub-agents. It really is, some people are saying game changer, but every feature that Claude Code adds is a game changer, because it gives you capabilities to do things. So what have we got? There's no authentication, so that was just a demo API, so there was no authentication. We'd want to add that. There is a connection string, but it's basically a local host one, so that's not necessarily a problem because that'll be replaced by a transform. Let's make some suggestions on missing database indexes, suggested using caching. It's suggested there may be some issues with potential things that it would need to go away and exercise to make sure they weren't there, but it's identified enough to say you probably want to just go and check these just to make sure that they won't work. Seeing some performance bottlenecks, and again, what we can do at this point is we could then actually get Claude to individually create a task for each item, fully define a plan for each item, and then go away and work on these individually. It's come up with some strengths as well: clean architecture, CQRS, comprehensive testing, domain modeling. So it's come up with the top 10 recommendations. Again, some of these maybe aren't relevant because it was a very quick 5-minute demo API to be able to allow us to go and do some other demonstrations. It's made some suggestions on caching, rate limiting, some real-time tracking, potentially a dashboard, some very sensible EF query optimizations, essentially a read-only DB context, make complete sense. And it's had some suggested features: search by tracking number, a soft delete. So obviously when you delete something, it's still there, but it's not deleted from the database, or it's put into an audit table. Some namespace inconsistencies. And apart from that, I think that pretty much covers it. So really, that was just a demonstration of subagents using this 5-minute Noddy API we knocked together that we've used then to add features on top of to demonstrate a lot of things that Claude Code can do. And we've then gone away and demonstrated some features where we get Claude Code right in spec flow tests, for example. So again, we've just leveraged that just to very quickly show you subagents in action, running in a parallel fashion to be able to do things. So that's all I've got for you today. So I hope you have a great rest of your Saturday. Look after yourself. Take care. Bye-bye for now. Bye-bye.